Okay, so we're going to fill in step 3 here. The first piece to understand today is that nothing is changing with the other steps. So step 1 is still, if there are parentheses, distribute. Step 2 is still, if there are like terms, combine them. We are just filling in step 3. Step 3 says, if there are variables on both sides, get them together. Okay, so this is talking about if we look at an equation and we see variables on both sides of the equal sign. So let's say we have something like 6x plus 4 equals 4x minus 8. Okay, so now when we look at this problem, right, here is our equal sign, and we have a variable on the right-hand side, and we have a variable on the left-hand side. Okay, so we have variables in both of these locations that we want to get together. And several of you have already talked to me about this because you were getting it confused with what we added last week. Right, and you were saying to me, well, Mrs. McKinney, I thought I needed to do the opposite sign here. And my statement to you was, no, these are on the same side of the equal sign. Right? These are both on the left. And when they're on the same side, we get them together with the same sign. When they are on different sides, right, when they're on opposite sides, one is on the right, one is on the left, we have to get them together with the opposite sign.
So we're subtracting 4x.
Right, so you're going to use the opposite sign of what it already is. Now, some of my students have rules that have sort of already been just solidified. Your teacher has taught you something like, always move the smaller variable, or always put it on the left-hand side. Okay, those rules are sort of guidelines. They're optional. It's to help you keep the same process, but they're not required. You can technically move either of these that you want to. I tend to be the type of person who always moves to the left, just when I'm thinking on my own. A lot of my students like to avoid negatives, so they'll always move what's smaller. There isn't a rule. Okay, anybody have a preference as to whether they would want to move the 6x or the 4x?
4x.
I think almost everyone in here, for whatever reason, would move the 4x. Okay, so we are going to look at this 4x. And we're going to look in front of it. Is this 4x positive or is it negative?
I mean positive.
Right? It's positive because we don't see anything there. So if we want to use the opposite sign, the opposite of a positive is a negative, which is the same thing as subtraction. Okay, so we're going to write it once on each side of the equal sign, and we're going to write it underneath where we have the like term. So don't write it here and don't write it here. Only one time on each side and only underneath where that x already is. Do you want to go now? Okay. So when we go to put these together, if you say, I'm terrible at combining like terms, type it in just like you see it. So if you want to see it horizontally, right, 6 is first, minus 4. So 6 minus 4 gives us what?
4, 2.
2.
X.
And then the variable just comes with it.
Plus 4 equals.
Everything else is just falling straight down. These cancel. 4 minus 4 is just 0. It's gone. And then we'll bring the -8 down with it. Right? This is a -8, so that -8 is coming down with it. Any questions there? Okay, then turn your page in your notebook to your next spot, and we're going to add in some examples of this. So we're going through the exact same steps that we went through last week. So let's say we have something like
Oh my gosh. Is that -5?
as opposed to what?
Supposed to be yes.
Like, are you asking if this is a negative or if this is a subtraction?
Yeah.
I don't know. You tell me. Is this a negative or is this a subtraction, class?
Negative to negative. Subtraction.
It's both,
Oh, it's both. Remember?
right? Do you remember? What's this word? What word is this?
Oh, read.
Or is it red?
Red.
Tread.
How do we know?
Oh.
Right? It depends on context. It's both of them. Same thing here.
I read it again.
Okay, so if we look at this problem, we're going to go through the same steps in that printed out list.
We haven't done yet.
So step 1 says if there are parentheses. So do we have parentheses up here? Yes. So what are we going to do, Rachel? We're going to distribute. So we're going to pass this out with multiplication.
You get the intro.
Right? So we're going to multiply, because when we pass out, we multiply. So 3 times 2 is
6x.
6x. 3 times -5,
Positive 15.
negative 15.
Equals 8x plus 27.
Then everything else is just falling straight down. Is that a question? Step 2 says if there are like terms, combine them. So if we look over here on this side of the equal sign, is there anything that we can combine? Nope. If we look over here, is there anything that we can combine?
Nope.
Nope. Step 3 says if there are variables on both sides. So do we have variables on both sides of the equal sign here?
Yes.
Is that a question? No, you're just saying yes, they are? Okay, so what variables do you see? Maharu, what variables do you see?
This is gonna be -6.
So you want to subtract this one, okay? So here are our 2 variables. This 6x is positive.
Oh, my eyes are watery.
Okay, so if we subtract that 6x from both sides, again, we're writing it once underneath each of the like terms. So what do we have left here?
Negative 15
Negative 15.
equals
8 minus 6, which is a 2x.
2x plus 27. Yes, sir.
Okay, then our next one says, are there any large fractions? Nope, we don't have any large fractions. Then our next one says, undo any addition or subtraction. So do we see any addition or subtraction up here?
Yes.
Yep. So how do we undo adding 27?
Subtracting 27 from both sides.
Okay, this has been a piece I've had to do with a lot of you.
Oh.
It's not that you don't know how to solve the equation, you're just not checking your math. Use the calculator if you need to. I don't care. I want you to get the number right. So what is negative 15 minus 27?
Negative 42.
Positive.
Negative 42.
That's not what I did.
Okay, so when you put this in your calculator, a negative 15 minus 27 is a negative 42.
I said a negative and a negative.
That's if you multiply. This says if you borrow $15 and then you borrow 27 more, you owe more money.
Yeah, okay.
Right? I mean, it'd be really great if we lived in a world that I could borrow money and then borrow again and then all of a sudden they have to owe me money. But that's just probably not going to happen, right?
Yeah, not yet. I haven't invented that yet.
Then what do we do last?
So divide 2. Then it's gonna go to 21.
We'll get x equals negative 21.
Wait, I think I did something wrong then. Big time.
You make 7. 27 turns into 7.
So I could have got the right answer.
Probably.
Yeah, you just turned that over. You dropped the 20 part.
Did I?
Are we okay on that one?
Yeah.
Okay, now, when we are solving with variables on both sides, it opens the door for some problems to come up. Okay, and they don't work out how we kind of think they should. So, for example, hold on. Let's say we're given this equation. 2x minus 5 plus x equals 3 times x minus 8. Okay, so we're still going down our same steps, right? That's not changing. If there are parentheses, distribute. So we're going to pass out with multiplication over here. Right, so 3 times x, that's that 3x. 3 times a negative 8,
24.
negative 24.
And then you bring the rest down.
And we'll bring the rest down. Okay, then it says if there are like terms, combine them. So do we have like terms we can get together on this side of the equal sign?
Yeah.
Yes, right?
Yes, yes.
So we have a 2x plus x. Are those on the same side of the equal sign or are they on opposite sides of the equal sign?
Same side.
So if they're on the same side, we use the same sign. So we want to do a 2 plus a 1.
Yes.
Okay, the next step, if there are variables on both sides of the equal sign. So now do we have variables on both sides of the equal sign? Do we have one on the right and one on the left?
Yep.
Yeah? So we're going to get these together with the opposite sign. Edgar, do you want to move 3x or do you want to move 3x? 3x, good choice. Okay, so we have a positive 3x. Okay, again, we're writing that on each side. What is 3x minus 3x? 0. What is 3x minus 3x?
So
So the only thing I have left over here is a negative 5. And the only thing I have left over here is a negative 24. There are no more x's. They do not get to magically reappear. You can't say, oh, I must have done something wrong. Let me add an x in there. Do you think you know what it is, Edgar?
What?
Oh.
I was gonna ask something.
Go ahead.
Because you said it can't magically appear.
Uh-huh.
I thought it's just an X, isn't it? Wouldn't it? No.
Nope. These are gone and these are gone.
Then it's no solution.
Why is it a no solution?
The X is gone. There's no X.
So we have to think about it a little bit further than that. We need to ask ourselves if this is true. Does negative 5 equal negative 24?
No.
No. This is false. These do not equal each other.
No, senor.
Right? This is not true. When this is a false statement, our answer is no solution. You can shut it on desk. Yeah. Yeah, it's fine. That makes sense? Okay, which means if we get a true statement, I mean, this is a really dorky example, but I want to make sure that we understand. Right? So if we were to combine our like terms here, what would we have left?
7 on 7. That's
Which is true. Okay, so here we have the answer of all solutions. Okay, this comes with a small disclaimer. Mrs. McKinney's math degree strongly says that the answer should be all solutions.
What if that was a negative 7?
Then it would be no solutions, because then it would be false. Okay? However, lots of times you will see this listed as infinitely many solutions.